Great. Good morning, everyone. My name is David Rosenberg. I'm a professor in civil and environmental engineering at Utah State University, and I also have a joint appointment at the Utah Water Research Laboratory. Most of my research involves systems modeling to inform water management. We're looking at urban water applications, management for environmental purposes, water conservation. And in this case, I want to introduce you to a project that we're just getting going. It's myself with Dr. Jim Staggy, who's a postdoctoral research fellow starting at USU just within the last few weeks. Jim, do you want to raise your hand real quick? And so unlike the prior presentations where you're seeing reports on work that's already been done, we're here to pitch an idea of a project that we want to do. And the idea is to use the reconstructed time series of flows from tree ring data that Justin just talked about to inform how we can better manage our current water systems in droughts. So the idea is to take the reconstructed flows, which we have in the Bear River, two locations, the upper Bear River from 800 AD to 2000 AD or so that Justin just talked about. Also another data set along the Rogan River from 1600 to 2000. And to translate what those flows might mean in terms of impacts on users, if those flows or if those droughts were to reoccur today. For example, what would be the delivery to urban and agricultural water users? What would be the reliability of those deliveries? How much shortage would people face? Importantly, how severe would those shortages be relative to the droughts that we've experienced in more recent and more memorable times? We also want to look at how can we mitigate those impacts? What alternative reservoir operations or diversions can managers today undertake to reduce the impacts? Now, to do that, to go from headwaters locations where the paleoclimate data is developed to the impacts on users, which are down in the valley, we need a way to deal with all the complexity in the system that's in between those two points in space. This is where the systems modeling comes in, looking at reservoirs, diversions, water users, agriculture, urban and environmental, and also the return flow. So people are diverting water out of the river, using it, and some of that flow returns to the river and may be available for use by other users. A systems model is really a mathematical way of representing all those flows. So to do that, there's three things that we are envision doing. The first is we have to disaggregate the paleoclimatic data temporally. We have to transform the annual reconstructed flows into monthly flows. And we have to do that because, one, the seasonal pattern of monthly flows changes based on the type of year that we're experiencing, as the chart gives you some indication of. We have month on the x-axis and the percent of total flow, the proportion of total flow on the y-axis, and the color ranging from light blue to dark blue represents the mean annual flow for the particular year. That timing of the peak changes based on the type of the mean annual flow. We also have to disaggregate temporally because our users are not using water the same amounts throughout the year. Their demands change seasonally. So we have a variety of potential methods that we're looking at to do this disaggregation. One is simply taking the average monthly pattern. Another is trying to tie to different tree species which put on their rings at different times of the years. Another approaches include statistical sampling, including trying to tie to some of the climatic patterns that Simon was mentioning in an earlier talk. Now, the second thing we have to do, besides temporally disaggregating, is to spatially disaggregate. Justin hinted at this or touched on this at the end of his talk. We have 2 locations where we have existing reconstructions of paleoflows that are shown by the red stars. There's numerous other additional sites in the basin, some 6 to 8 shown by the blue diamonds, where we also are seeing significant inflows for the Bear River that we don't have paleoclimatic data for yet. But we will need to represent these inflows if we're going to completely or correctly track flows through the entire river basin. One of the important things in doing this disaggregation is to make sure that we're maintaining the correct cross correlations between, for example, flow that we observe in the Bear River headwaters at the Utah-Wyoming border and flows in other locations in the basin. The third thing we need to do is also to expand the spatial extent of our systems model. Right now, our model is really centered, and the data that we have for users, agricultural, urban users, and reservoirs, diversions, and return flows is really focused on the lower Bear, Utah portion of the basin. This includes both existing and also some proposed infrastructure that's proposed as part of the Bear River project. We need to add the additional demand sites, additional inflows, users, and return flows in Wyoming and Idaho so that we can connect between the locations where we have the tree ring data and where most of the use occurs. I have in question marks hydropower facilities as important features to add. This is potentially an additional user we could include. So here are some of the ways that we could potentially use this model. First is to quantify the impacts on users if paleo droughts were to reoccur. Where are shortages going to occur? Which users are going to be facing difficult times? When into drought events are those shortages going to occur? Several of the swings, climatic swings you're seeing in some of the reconstructed flows last more than 2 or 3 or 8 years. When into those droughts might we expect to see difficulties? And also, how is the severity of these impacts going to be relative to the droughts that we, as managers and as people who have lived here in Utah, experienced in our own lives? This is going to be a really key way to connect. We can also talk about the likelihood of impacts. There's a variety of uncertainties that go into the forecasting or estimating the tree ring reconstructions, the corresponding stream flows, the corresponding outputs from the systems model. How can we describe those in a way that are realistic and also accurate, yet still provide useful information? We can look at the effects of proposed infrastructure on mitigating drought response. We can also talk about adaptation strategies or propose or suggest or test adaptation strategies. And finally, we can compare all of the above impacts to the impacts of other factors that aren't necessarily climatic related or climate related, such as population growth. So in the facilitated discussion, we'll have a chance to go into some more of the questions and some more of the ideas that are behind this. Here's my and Jim's email contact if you want information. But we will be, as I said at the beginning, this is a study that we're starting so that we feel that there's a really good opportunity to contribute input, and we're definitely interested and want to hear your feedback and suggestions, needs, and desires related to this work.